Hello everyone again. My name is Hiroko Tsuzuki, and I'm a Public Relations Officer for the National Astronomical Observatory of Japan. I am also a collaborator for the Office for Astronomy Outreach. The office is working on our global project, Dark and Quiet Skies. This video is the second part of the interview with two astronomers, Professor Ohishi and Dr. Horiuchi, about the office called Spectrum Management Office, which is working to protect the environment for radio astronomy observations. Thank you for joining us again, Professor Ohishi and Dr. Horiuchi.
Thank you for having us.
Thank you very much for inviting us. This is a very good opportunity for us to advise our activities to the whole world. Thank you very much.
Thank you. This next question is for Professor Ohishi. What is Spectrum Management Office? What do you actually do? And what is the aim of your office?
This is a bit long story. The Spectrum Management Office at the NAOJ was established almost 2 years ago, April 2019. Its main purpose is to avoid radio frequency interference as possible. That degrades radio astronomical observations. Communication by using radio waves is called as radio communication. It has over 150-year history since Marconi succeeded to communicate between Italy and the United States. People have to use the same frequency for communication. And an international organization to regulate the frequency use was established at that time. Radio astronomy has shorter story than radio communications. In 1932, a US physicist called Jansky discovered cosmic radio signals from the Milky Way galaxy. In 1951, the famous 21 centimeter neutral hydrogen line was discovered. And astronomers knew that the most abundant atom in the universe is hydrogen. Because the cosmic radio signals are extremely weak and can be hidden by man-made radio waves used for radio communication, then there was a need to protect radio astronomical environment from man-made radio waves within the international framework. NAOJ, since its former Tokyo Astronomical Observatory, has participated in the International Regulation Organization. This is the International Telecommunication Union. But such an activity was made on a voluntary basis. In recent years, radio communication use higher and higher frequency ranges, which may degrade millimeter wave radio astronomy observations, where many radio astronomers, especially in Japan, conduct their research. So NAOJ seriously discussed possible interference to such frequency range and decided to establish the Spectrum Management Office in order to demonstrate that we will officially work for it. The office has a mid and long-term mission to mitigate light pollution. But 2 years ago, when this office was established, we did not intend to work on the light pollution. Only 2 months later, of the first Starlink satellite were launched. we have been involved with the light pollution problems. So, regulations of radio resource are made both on national and international levels. Industry people always propose new radio services, including Wi-Fi's, mobile phones, and so on. When new proposals are submitted, national and international regulatory bodies call for many meetings to find a way how to coexist with incumbent radio use, including radio astronomy, without causing interference with them. We, Spectrum Management Office participate in many such meetings and request industry people that they have to find solutions not to cause interference with radio astronomy.
Thank you very much, Professor Oishi, for describing in details. I understood about the history and your office and also what you're actually doing about it. This is the next question. Why do astronomy and other technological industries need to coexist?
Oh, yeah, the answer is simple. Both are important to our society. Radio use has made our life fruitful. Okay, astronomy has unveiled many new insights, such as the age of the universe, how stars and galaxies are formed, discovery of exoplanets, and so on. Many people are interested in, for example, black holes. We have many visitors to our observatory, and they always ask about, black holes. These days, almost all people use, mobile phones. We can communicate with other people everywhere with mobile phones. Although this is sometimes annoying, for example, to me, I'm busy. Mobile phone calls sometimes, interfere with me. So this is a problem. Anyway, our modern life owes to such radio use. Therefore, astronomers and industry people need to respect to each other. So this is very important.
Yeah, they're very important. Could you give me some recent examples?
Okay, today I will give you two examples. The first one is a coordination between radio astronomy observations at around 10 gigahertz. Its wavelength is about 3 centimeters. And famous mega constellations such as Starlink that Horiuchi-san already mentioned. There is a protected radio astronomy band for between 10.6 and 10.7 gigahertz. The mega constellations use a frequency range between 10.7 and 12.7 gigahertz range, just above the radio astronomy band. The radio signal from satellites are very powerful and leaks below 10.7 gigahertz into radio astronomy band. This will cause serious interference to the radio astronomy observations. So we made tough negotiations with Starlink and OneWeb people and the Mega Constellation people. And we were very happy to agree that satellites do not emit radio signals between 10.7 and 10.95 gigahertz to 150 megahertz wavelength when the satellites see a radio telescope. So this is the first example. The second example is so-called collision avoidance radars onboard cars. Other name is car radars. The radars use millimeter wave range between 76 and 81 gigahertz, where many important spectral lines from star-forming regions, galaxies exist. Radar chip industries pushed, many governments who regulate radio resource very hard toward introducing the collision avoidance radars for securing traffic safety. Of course, this is very, very important for our life. But we requested the industry people saying that when a car enters some area around a radio telescope, why don't you switch off the radars automatically or manually? But industry car industry people, I will say chip industry people said, it costs a lot of money. This is not the case. So they use political power to refuse our requests. But um, car manufacturers, some car manufacturers are very kind, and they introduce switches to switch off the car radars when drivers approach to a radio telescope. So yeah, there are many other examples, but I'll stop now.
Mhm. Thank you very much. I think it's important to talk with interesting people. It's very interesting. What is Japan doing to prevent light pollution?
Yes, as far as I know, there are activities towards improving the light pollution problems. For example, the Ministry of Environment has a program every year to promote Japanese people to recognize the importance of dark skies. There is a campaign to measure sky darkness. There is a small measurement machine. The measured darkness data is collected and publicized on a website prepared by the Ministry of Environment. And I can add another thing. There are a few local governments that find protection of dark skies economically feasible. In other words, they can invite many tourists, stargazing tourists, because people can enjoy watching very beautiful stars and Milky Way galaxies. If we stay in big cities like in Tokyo, it is almost impossible to enjoy, seeing the Milky Way galaxy. So people want to visit such, dark areas to enjoy their life. And finally, I want to add one technological thing. There are two appliance companies in Japan that develop dark sky friendly LED lights. So these days, many cities and villages have introduced such, very good LED lights in order to keep dark skies.
Thank you. I'm glad to hear that the Ministry of Environment and also the local government and also the two appliance companies are working on this issue. Thank you, Professor Oishi and Dr. Horiuchi. Is there anything you would like to add before we wrap up?
Thanks, everyone. Thank you for giving us a chance to talk about preparation and our research. Thank you.
Thank you very much, Suzuki-san. I would also thank the effort by the IAU and the OAO. This is a very good opportunity to advertise how astronomers suffer from contamination of observational environment and how we have been struggling against this problem. Our office would like to collaborate with you toward keeping dark and quiet skies in optical, infrared, and radio regions. Thanks again.
Thank you, Dr. Horiuchi and Professor Ohishi, for your time today. It was a pleasure to speak with you both. And thank you to those watching at home.